And good morning to all of you. Good morning to all of you. So today is the last session. Actually, before this sections, all the dignitaries and all the students and all the staffs from all over our, I mean to say that from country are well being known about the theoretical concepts of these solar things. But today I am going to present some of the livelihood products, and that should be the live demonstrations like your solar water pumping system, DC microgrid solutions or DC microgrid systems, and also some solar home lighting systems that can be installed how through the calculation, a small calculations, and also some hybrid solar systems, roti rolling machine, and that if you say rice solar machines, and millet machine, milking machine, photo wheels. So these are all some livelihood products which is operated by the solar power. And also we have one of the Snyder Electrical Lab, which is the application of renewable energy lab. The total lab is converted into DC system, and some of the panels are installed our backside of the lab. And total this room is actually well calculated and well it is less consumptions of energy, and there is no grid for this lab. Only the DC system is here. So in this contest, I would like to request you, though there is some PPT is there and it is impossible to present the PPT. So I will share through Rana sir, and I will share my YouTube channel where there is a lots of designing and calculations regarding that if you say inverter sizing, troubleshootings of inverter, how can we pick the troubles from the inverter, from the charge controller, retrofits, and also some of the electrical wirings and some of the basic knowledges regarding basic electronics or soldering practices. Everything's are in my YouTube channel. And after the end of the session, I will share my YouTube channel as well as my number. If is there any problem, then you can call me by my number and also message me. Thank you. So now I am going to switch through my mobile because I have just going to demonstrate the live demonstration. So please stay with and let me have 5 minutes to start through my mobile. Thank you. So now welcome. So first of all, let us talk about one of the livelihood product, that is hybrid solar system. So, hybrid solar system in the sense that we are using here one hybrid inverter, that is multi-purpose multi-mode inverter. That means this inverter uh, can be used to charge the battery from the AC as well as from the solar panel. And also the output of this inverter is also for AC appliances as well as for the DC appliances. So that in this context, we can say it as a hybrid system, hybrid solar system. Suppose in some area there is also grid and there is also the capabilities for the DC system. So we can convert this system into a hybrid system. That's why we can able to use AC as well as the DC system. And particularly this system is well calculated. One inverter, here you can see a inverter that is 105,000 volt ampere inverter as well as a 24 volt system inverter. It will charge two batteries at a time and also one battery will be charged. So you can see here, I am connecting through AC to this inverter. You can see here. Yes, let's see here. The solar panel is connected to here, and also the output is connected to here, and it is the output of AC. And here you can see some of the. This is the. You can see here the AC appliances are here, and one TV, LED TV is connected here. Just wait, I will show you. Here, this is the DC fan and DC light, and it is AC. And this is, you can see here, these are all AC appliances and one side DC appliances. So at the same time, we can use AC appliances and also DC appliances. And at the same time, we can be able to charge the battery from AC as well as from the DC. Here you can see. Here you can see from solar panel, the battery is charged. At the same time, AC mains is connected to here. So sorry, I mean to say that from AC mains, the battery is charged. And at the same time, the power can be delivered from this inverter through DC slot. You can see here. Yes, you can see here. This is the DC slot and this is the solar power input. Yes, you can see here. You can see here. So for this reason, it is known as the hybrid solar system, and it is a very good system for the livelihood products. So now next switch over to DC system, total DC system. Here you can see it is a total DC system. That means we can be able to make one room total DC where there is not possibility for the AC system. Some remote areas we cannot be able to install the AC system. So for that reason, we must have to take this type of systems, which is well calculated, and somehow you can see one fan is there, one LED light is there. Light is there. Yes, it is also TV is connected to here, and you can see a DC fan and also one slot for mobile charging or mobile charge. And all these appliances you can see are of total 40 watt. So we have designed a small system. It is total 40 watt system. So the 40 watt system, in the sense we are calculating fan, TV, mobile charge, and also this DC light. Total calculated 40 watt. So total consumption of this system is 40 watt. And the calculation is in the best. The energy consumed by all the appliances is for 5 hours. So 5 hours in the sense 40 watt and 5 hours. That is 200 watt hour. So energy consumption is 200 watt hour, and the total load is 40 watt. So for calculating the charge controller and for the battery and for the panel, just one mathematical formula is there. Just I am going to present it now. Suppose let us take total watt consumed by this system is 40 watt, and somehow the battery voltage is 12 volt. So you can be easily able to say how much current will draw this system. It is easy, not difficult. So total 40 watt divided by 12 volt. So almost all it is 3.33 ampere. So 3.33 ampere is the system current which is consumed by all the appliances. So easily you can calculate the controller capacity. Though the controller is controlled by 12 volt battery, so we can say that this controller is 12 volt, and the current consuming capacity of this controller is 12 volt 3.33 ampere.
But as we know that we can never get such like a controller like 12 volt and 3.33 ampere, so that we must have to take 12 volt, 5 ampere or 6 ampere, or somehow you can say that 10 ampere. So charge controller capacity for this small station is 12 volt and 6 ampere. Then comes to battery. So arbitrarily you can never put a battery here. You can put the battery as per your calculation. So as you know, a little bit of knowledge among you, I think that you must know the I mean to say that depth of discharge and state of charge. So according to this, you must have to know the depth of discharge of a lead acid battery. It is somehow 0.7 to 0.70%, 20%. So better you must have to choose the less. So that is 70% depth of discharge of this battery capacity. So now you must have to calculate the ampere hour of the battery, the minimum ampere hour of the battery. So in this regard, one general common formula is there. You have to calculate that formula. That battery capacity, it is total load current. You know that total load current is 3.33. And operating hour, that means operating hour in the sense, though this is a DC system, so you must have to consume less power, so that it is well known to you that you must have to use the appliances according to your battery. So let it be 4 hours or 5 hours. So though the total current consumed by the system is 3.33 and you have to use total 5 hours, so total load current multiplied by using hours, and another constant term is that is autonomy. That means back of hour or back of day. Suppose we have to take the back of day is 1 day, so autonomy you will have to take 1 day. So that the formula is total load current multiplied by using hours multiplied by autonomy divided by depth of discharge. So according to this formula, 3.33 into 5 into 1 divided by 0.7. So the output is 23.8 ampere hour. So 23.8 ampere hour is not a exact ampere hour calculated battery. So the nearest value you must have to take 40 ampere hour. So here a battery is connected here. So 40 ampere hour 12 volt battery is connected to the system. And the main important thing is that how to calculate the panel capacity. The panel capacity is much more important. So for this reason, there is also a little bit small formula. You can easily calculate and you can easily demonstrate. You can easily install in your home also. This is a small DC system. So for this purpose, the formula for the calculating the solar panel sizing is, it is very simple. So in the first step, you have already calculated the total energy consumed by the system, that is 200 watt hour, and you must have to take the autonomy factor here and good sunshine hour. So according to your area, you must have to choose the good sunshine hour. So here for this station, I am using the good sunshine hour is, that is 4 hours. And so far as concerned the efficiency of charge controller, let's have take it is 95%. So this PWM charge controller has the efficiency 95%. So total calculation by the system is energy required by the load, that is 200 watt hour into autonomy 1 day divided by good sunshine hour, that is 4 hours into 0.95. So that the total watt of the panel is 52.6 watt peak, which is exactly. But here one common sense is applied. 52.5 watt 6 of a system of a panel you can never get. So that the near watt peak of the panel we have taken here 75 watt. So this is the calculation for a small DC system. So it is also a very good I mean to say that livelihood product of a solar DC system. So next, switch over to our next livelihood product, that is DC microgrid solution or DC microgrid system. Here actually we are demonstrated two small rooms of one village, and the DC microgrid system or DC microgrid system is completely analogous to your SCLT line. You must have knowledge about SCLT line. Exactly like that, some panels are installed 1 or 2 kilometers away from here, and it is in between 1 or 2 kilometers. Why I am saying that DC microgrid system is capable for 1 or 2 kilometers in between that. So some of the panels are connected, and that output of the panel must be 110 volt to 230 volt, which comes through the LT line port and connected to this SPD. This SPD, and all these two rooms are connected to two charge controllers here, and these charge controllers have the capacity to step down the 230 DC volt to 14 volt. Mind it, it is very much important. The capacity of the charge controller which is connected to in each room is 14 volt, because the 230 volt is stepped down to the 14 volt. As we know that each and every battery of 12 volt, that nominal voltage is 12.6 volt, and for charging a battery it is required to multiply a multiplying factor, that is 1.0 or 1.2, so that we will get almost about 13.96 volt. So for charging a 12 volt battery we require not 12 volt, but it is somewhere in between 14 volt. So though this controller has the capacity to step down the 230 volt, so we can be able to charge this battery through this controller for 14 volt. So easily it can be charged. So from this battery we will distribute our load like the DC system, TV, LED lights, fans, and some of our other appliances like this. So this is all about the DC microgrid solutions. So now I am just going to demo. I'm just going to announce something. If is there anything else doubt, then call me personally. I will clear all of the doubts, because now there is a stipulated time for me to demonstrate all the systems with some livelihood products. So please come to the next. So here is another livelihood product, that is solar water pumping system. You can easily install this water pumping system in your garden for lift irrigation point, and as well as also your drip irrigation points in your gardens also. But for demonstration purposes, we are just arrange or set this motor into two chambers of water. So one is inlet and another is outlet, and it is connected to the solar panel by retrofit, and another frequency driver is connected to the panel. Now just I am going to run this. You can see when I run this, you can see here, and it is running, and from this side, from this side, now this side water, it is going through, and it is stored here. So you can be able to, now the I am of the switch. So you can be able to install this type of water pump system in your garden or in your also from some lift irrigation point. So this is all the stations which I demonstrate here. Now another important thing I am going to demonstrate, that this room is operated through total solar panels. So you can see here some fans are there, lights are there, and some LEDs are there. So every appliances in this room is total out of AC. So we are not consuming any type of energy from the AC source. Just we install the panels outside of this room, and from that solar panel we will get the power to run the all the appliances. You can see here 1, 2, 3, 4, 5 or 6 rows are there. Each and every rows are connected in parallel but not in series. It is much more important to know. Every appliances are connected in parallel, because total load in this slab is 800 watt. So for 800 watt, we are installing 1 kilowatt of panel. 1 kilowatt of panel. The output or maximum voltage of the panel of each is 18.36 volt. each panels are connected in series. That's why we will get 36.75 output volt. So in peak time we have the output 40 volt. So now here you can see, for this we are connecting two batteries. Two batteries are connected in series. The capacity of the battery is 12 volt and 150 ampere hour. So 12 volt and 12 volt, 24 volt batteries connected in series. Though the output of the panel is almost all 39 volts, so it is sufficient to charge the battery. But one important thing is that current factor. As you know that the charging of the battery or the fast charging of the battery actually depends upon the ampere hour of the battery. As this battery is 150 ampere hour, so 1/10 of this battery current will be able to charge the battery fully in a shortest time. So that minimum of 15 ampere current is required to charge the battery. So that here the panels are connected in series. Two panels are connected in series. So you know that when the panels are connected in series, then voltage will rise and the current is the same. So current is the same in the sense the maximum current of this panel is 8.36 ampere. Though it is 8.36 ampere, so there are three strings. So three strings are connected in parallel, two panels are in series. So as per the calculation, you must have to multiply 8.36 into 3, that is 24 point something volt. So if it, so though it is required 15 ampere current, so almost the maximum current is flowing from the panel, that is 24 ampere. So easily it is the battery is charged. So now you can see here. So this is the charge controller which I have installed. So you can sorry, it is now 24.2 volt. It is the maximum for the battery, and you can see the input you can also see here 39.8 volt. As I have said before, two panels are connected in series and three strings are there. So you can be able to catch it. 39.8 volt is sufficient for charging the battery. So these are these are the things which are actually the livelihood products. Now in the next step, I am going to demonstrate some of the roti rolling machine as well as the rice huller machine. Practically, I am working. I am going to demonstrate through some floor, through some padding. So please stay with for some minutes. Please come. So here you can see this is the rice huller machine. This is the rice huller machine. So technical specifications of the rice huller machine and operating procedure and the panel specifications, everything I will demonstrate. Next, I will demonstrate about this. This is the sorry. This is the roti rolling machine, and each and every parts of the roti rolling machine I will demonstrate. And this is the what is the capacity and how can we make roti from flour. I will demonstrate lively. Then this is the floor machine. This floor machine also, how can it operate, I will show you. And also it is a paddy, oil or pulses processing machine. And next, it is the oil extractor machine. I will demonstrate this. And next, it is the DC press. The DC press, how can it operate? What is the specifications of the DC press? And here you can see it is the milking machine. It is solar operated milking machine of single cluster. I will show. Next, it is the blower. This is blacksmith blower. I will demonstrate. Next, another livelihood product. Some of the products are there. That is our potter wheel machine and sewing machine. So all the things are livelihood products. So first of all, one by one we will go. So first, let's take the solar power rice huller machine. So please watch this. So solar power rice huller machine. So it has the capacity. For handling some paddy, that is 60 kg per hour. Operate such a way that in 1 hour we can use 60 kg of paddy. Then rice producing 38 kg per hour, and we have to work as per the specification 6 hours per day. And if we use 25 days per month, then we will get our output. So technical specifications is 250 watt peak, 3 numbers of panels are installed, and the solar power control unit, it is 40 ampere hour. It is 40 ampere. That is 40 ampere and 24 volt. And battery is 24 volt, which is connected for the both the purposes. Now, live demonstration. Please watch. Here you can see the controller is connected here and panel is somehow above. You can see here I have some paddy here, and this is a DC motor, and it has the capacity. It is 24 volt, and it is 24 volt and 19.3 ampere. I think you can see here it is written, and this motor will operate the rice huller machines. Now, just on the MCB, then it is glowing. Now, according to the speed, this is the regulator, so you can able to rotate this. Suppose let us take it to 2. So now it is running. You can see it is running, but there is no output here, and there is no first here, and there is no first here. So if I open this, then you can see here now this is running like this, and it is here. Now I am now department of the machine. So can I have one question here? Is it clearly visible to you? Solar power
Yes, sir.
isolar machine. Hello.
Yes, sir. Visible.
Yes, sir.
Yes, sir. Vijay.
Yes. So actually, it is operated. It is operated through solar. Exactly, the panels are backside of our department. So for the timing, I am unable to show you. But in my YouTube video and also the recorded video is there. I will share through Rana sir. There you can see how the panels are connected for total our for this department and to run all the appliances. So this is one solar rice roller machine. Now another interesting part is roti rolling machine. So one is roti rolling machine. You can see here. This is the roti rolling machine. So I will show you the different parts and operating procedures and operating systems through some of I have also with me some floor there. Yes, I have also taken from my home today. So I will demonstrate it just now within you. Please 1 minute. 1 minute. So now welcome back. So first let's take one look of this roti rolling machine. So here you can see this is pressure controlled or foot press. This is pressure controlled or foot press. This and this is your roti rolling plate. This is the rolling plate, roti rolling plate. And this is roti roller. This is the roller. This is the roller. And it is the press hand for the roller. This will have to see here. Like this. And it is flattering plate. This is flattering plate. This is the flattering plate. And it is the handle for press the plate. And here a controller is connected. Two batteries are connected. You can see two batteries are connected in series because 24 volt required for this. 24 volt required. And controller is here. This controller is here. And the technical specifications of this, the technical specifications of the roti rolling machine, that is panel 150 watt and which have the open circuit voltage 21 volt and charge controller is 10 ampere and 24 volt and battery, two batteries are connected in series because it is a 24 volt permanent magnet DC motor 150 watt 24 volt and 1500 rpm and switch which is connected is 15 ampere switch. So maximum energy consumptions per day, maximum energy consumption per day is 0.4 unit, though it is operated through DC. So maximum energy that is consumed 0.4, only 0.4 units, only 0.4. Then let's have a look. How can it operate? Here it is some floor. And now you can put this here, then press like this, and it is flattered like this. Okay, so now let us take two polythenes like this, and let some oil or ghee here. Is it visible to you all?
Yes, sir.
Oh yes, some oil is here. You can go through like this, or easy rolling. It should be some refined oil or some ghee. But here I have no refined oil or ghee. It is Dabur Amla oil, hair oil. So it should not be used in home. So here it is, and pour the prepared dough here. And next, put some oil here, like this. And make it something like, then keep here. So after that, let us press. Now I think it is puri. And so you can see here. So though it is not professional, so I think it is not a perfect roti. But in 1 hour, it can deliver up to 1,000 roti. As per the calculation, we can use, if we can use professionally, then we can be able to extract the roti 1,000 per 1 hour. So though the consumptions per day is 0.4 unit, so it is very easy or very I mean to say that it is a livelihood product. So where there is no electrification area, we can able to use, or we must have to use this type of products. This and also a rice oil product. So all of you, have you seen these products? Rice roller, roti rolling, and all other stations, hybrid, DC systems, water pumping systems, DC microgrid systems. So in between this within 5 minutes. So if is there anything else to ask me, then please ask. Hello. So it is a live demonstration session, so that it may not visible to all, but I hope maximum all of you can be able to visualize this. And if anything else regarding this rice roller or roti rolling or any other products demonstrated by me previously, then please ask to me. Hello. Hello.
Yes, sir.
हाँ.
Sir, continue.
अच्छा ठीक अच्छे. तो next आउ गोटे देखौछि आपण मानको. Next होछि, so this is the millet paddy oil pulses processing machine. So you can see this type of machine. This is the filter, and here the air blows, and when I on, you can see here. And it is another so next a DC freeze. So if this type of freeze is also operated through DC, now I have to on this machine. So please show you. This is a DC freeze, which have the capacity of 73 watt. 73 watt, and the system voltage is 12 volt. One battery is required, and panel 100 watt panel and 18 volt. That is sufficient. And battery, it is 200 ampere hour and 12 volt. And controller capacity 20 ampere and 12 volt. And it is 100 liter power. So you can see here, this is the digital display, and the battery, somehow the battery is low, and you can operate this. You can operate this. You can make your freeze. Sorry, wait, just wait. This is the inside of the freeze. You can see here. And somehow it is now 32 degree centigrade. Though battery power is low, I think it is not working now. Sorry, there is something battery power loss, so I am unable to change the temperature. Now it is 32 degrees centigrade, this temperature, and you can see here it is totally DC operated freeze. Total DC operated freeze. Compressor is inside here. You can keep something here, and also, and one is USB here. You can charge your mobile also from here. and if there is some error, then it will flow, it will reflect like this. And another livelihood product is that is milking machine. So here you can see it is a single cluster milking machine. You can see here there are 4 nozzles here for a cow. It is a single cluster because at a time we can use this machine for 1 cow, and these are connected to this tank. We can put the milk here and we can check the pressure. Sorry, we can check the pressure here. This is the, we can check the pressure, and almost all it is also operated through 150 watt peak, 2 panels, and also 2 batteries required for it is 24 volt. 2 batteries are required. So this all the things which I have demonstrated you, it is the all the livelihood products. The another floor machine is also here. It is also operated through DC. So you can hear. You can change. And if we pick here, then we will get flow from here. Here we will get. So these are all. So this is all some of the livelihood products which can be used in remote areas where there is no current or there is no facilities for AC sources. So please ask anything else from this, then I will clear the doubts. Please ask me. Okay, sir. Sir, actually, our exactly our FDP is meant for some livelihood products, and exactly what we can do through our solar power. So in our here in our university, we are we already designed hybrid solar system, solar DC systems, microgrid systems, and also some of the systems which on-grid systems we have also designed in our department, in our lab also. And some important thing is that our students are also designed some of the solar emergency light. Then some of our students are also designed solar street lights, emergency lights, street lights, and also they design some of the LEDs, DC LEDs, which can be used for solar power. DC LEDs are also used for solar power. So just I am going to show you one DC LED is here within me. So you can see here. Sorry. So this is, you can see here, this is DC LED. This is DC LED. And also one solar dryer which is designed, it is a hybrid dryer designed by our students. So it is it's in operating conditions, solar dryer, the students are designed here. So I would like to request, so if anything else, please ask me now. Yes, Rana sir.
Yes, sir.
Yes, please ask if anything else.
Okay, the participant, if any query can ask to limit Teacher Subranjan Nayak, will clarify your doubts regarding any product. If you help, require any help regarding installation or any product related to solar PV, you can ask him.
Sir, any type of doubts regarding the installations, the calculations, because we have designed exact calculations for our lab, exact calculation. So I can demonstrate you the exact calculation. There is no problem. And if you say that something like inverter, suppose one inverter is there. So how can we install a inverter to charge 24-volt system, 12-volt system, and also 48-volt system? So I think there may be some doubt regarding the inverter, because some of us have a little bit idea that the capacity of the inverter, that is somehow it has been written that 870E, 750E, and also 12 volt, 24 volt, 1050 VA. So according to this specification, we must have to install our system. That's why we can be able to get the exact output. Suppose there is a wrong connection or wrong calculations, and we cannot find the exact problem. Why the batteries are not charged? These are the new batteries, but the batteries are not charged. Somehow the battery may be fault, the inverter may fault, but it is not exact the solutions. We must have to calculate. जैसे कि मैंने पहले कहा, अगर हमको तो 24 वोल्ट बैटरी 150 एम्पियर आवर का तो चार्ज करना होगा, तो वी मस्ट हैव टू टेक an inverter which is definitely 24 volt capacity. That means it has the capacity to charge 2 batteries at a time. And as you know that charging of the battery is in series, but the output load must be in parallel. The output load must be in parallel. You can never use in series. Charging series and discharging parallel. And also in our room it is 800 watt, but I have the panel 1 kilowatt. But one question is there: each and every panel, two panels are connected in series, so that how much output watt? It is only 360. So how can it be possible to manage a 800 watt room? It is the question. It is the question. So that here we are designing in such a way that the load should be parallel. So at a time 360 watt load and at a time 360 watt output from the solar panel is enough. So this is the mathematics. If we only go through theoretical concept, then somehow we may not be able to practically install. So this is the mathematics. So I would like to request all of you, if is there any doubt, then you can call me through my number 198611 number is there, and also I will share my YouTube channel where there is lots of things regarding the inverter sizing or inverter. I mean to say that the fault of inverter, the difference between IGBT and MOSFET. What is the minimum idea, minimum knowledge to know a layman that my inverter is shut down? So immediately I took this inverter to the workshop, and he told me that your card is out, so you must have to change your card. So 2500 goal. So this is not the fact. You must have to know the exact fault. Same thing. ऐसा क्वेश्चन ऐसा नहीं है कि हमारा इन्वर्टर ऑलवेज कार्ड इज डैमेज, but we must have to know the practical concept, the practical things about the our system. A minimum fault can cause a huge amount of money. So in my channel there is also some little bit idea about the inverter, about the sizing. Basically DC sizing is there. Basically DC sizing, water pumping system, microgrid system, total DC system is in the channel. So if anyone else ask me now, then please ask. So I think we have a little bit time, only 8 minutes to go. So please ask me.
Hello. Good morning, sir.
Very good morning, sir.
I'm Rothiranjan
Yes, sir.
Mohanty. Yes,
Yes, sir.
I have one doubt
Yes,
regarding
sir.
actually very nice
Yeah.
presentation. You have shown practically many things. Thank you. Thank you very much for that.
Okay, sir.
Actually, I have a doubt, sir. The rice holler machine you have shown us that is
Yeah.
operated in DC motor, but in commercial scale we are using the machines that run by AC current.
Yes, sir. Yes.
So, is it possible that by incorporating an inverter system, we can run that commercial haulers also by DC solar cells?
Sir, actually, particular this machine which I have shown, it is permanent magnet DC motor. So it is operated 24-volt DC system. So we may not use some inverter to convert DC source to AC. So it might not possible to use this type of machine through AC because it is already built up the DC motor system, sir.
Yes, sir. I understand that. But my
Yeah.
question is that, sir, the commercial machines, the
Yes.
haulers that we actually use, that runs by AC current.
Yes,
So,
sir.
is it possible to run that machines by converting the DC current from solar cells?
Oh, sir, definite, sir, exactly. If we want to run that commercial machine from the solar cell, it is possible. There is no problem regarding that because we have to calculate in such a way that the particular horsepower of that motor, particular current drawing capacity of the motor, commercial used motor, we must have to calculate in such a way that we will install our panel and we will install our sizing the battery as well as the inverter. And we must have to make it either 24-volt system or 48-volt system, but not possible for 12-volt system. We can be able to use.
Okay.
Yes.
Hello.
Hello, sir. Yes.
Hello, Nayak sir. Anup Sharma here.
Sir, good morning, sir.
Good morning. I wanted two questions for livelihood purpose.
Yes,
And
sir.
there is some poultry farm which we run by hatching machines, electrical hatching machines.
Yeah.
Can you design
Yes.
hatching machine, solar hatching machine, or for washerman you can design the solar washing machine?
Solar washing machine.
Yeah.
Sir, actually, still now I have not designed that.
In
But
commercial purpose, industrial purpose, not small.
yes, sir. Yes.
Yes. So my question is there,
Yes,
some
sir. We can.
can you please? Hello.
Sir, yes. If
Yes, please.
yes, sir. We can do, sir.
Okay.
Sir, we can do. If that washing machine, it may be a, I mean to say that automatic or semi-automatic. If we have automatic machine, then we have one motor, single motor, that is 375 watt. But if you have a semi-automatic, then we have two motors. One is spindle motor, and so next is your wash motor, or that is your, I mean to say that is agitator motor. So in this case, automatic machine we can easily design, but in case of semi-automatic, we have to operate two motors of 375 watt each. So we can design also. There is no problem, sir. We can use
some of the dry cleaners and laundry asking for design industrial purpose. So I ask you these questions.
Sir, definite, sir. We can use BLDC motor, we can use half motor, we can also use permanent DC motor. We can use, sir. There is no problem regarding that. We can.
Okay. And for hatching machine or for poultry farm?
Sorry, sir.
Hatching machine for poultry farm. Electrical
hatching machine. Sir,
Yeah.
it can, but just we must have to know the capacity. The capacity, if it is within 1 kilowatt, then we can easily do that. But above 1 kilowatt, somehow the DC current will consume more. Definitely. So
because
within 1
I
kilowatt,
read
we
some
can design.
research paper and mentioned it, if you run the hatching machine by solar energy, you can produce
sir.
more than 40% production of egg.
Yes, sir. Right.
what is the reason, but I don't understand. In some research paper in US, I studied
Yeah.
40% production growing by solar energy in comparison
Yes,
to
sir.
alternate normal energy, non-conventional.
Normal. Yes, sir. Sir, we can do. Sir, we can do. We can do
Okay,
polytech factory. We can run through the solar power. There is no difficult regarding that. But we have to go in such a way that we can be able to do that, sir.
We provide the technical specification of hatching machines.
Yes, exactly. We should have to know that exact technical specifications, because the main thing is that motor to run.
Okay.
Okay, sir.
Thank you.
Welcome, sir. Okay, sir. Anything else, sir?
No, sir, I think all very result whichever been asked. So we'll move ahead.
Sorry.
Okay, we'll move ahead, sir. Thank you. Thank you,
Welcome, sir.
Smriti Naik, sir, for your nice explanation and presentation regarding the livelihood product. It is really a good experience about this utilization of renewable energy versus livelihood. Thank you once again.
Thank you, sir.
Smriti sir, thank you.
Thank you, sir. Thank you.
Thank you.
Welcome, sir.
So with this, we have concluded all the session of this 5 days FDP, and we'll move ahead towards the valedictory session of this FDP. So I'd like to welcome Dr. A.M. Mohanty sir, Pro VC or Pro Vice Chancellor, Century University of Technology Management. Professor Jagannath Padi sir, Director, Century University of Technology Management. Dr. Abhinav Vishal sir, Center for Renewable Energy and Environment, CUTM. And I'd also like to welcome I think Prashant Mahanti sir is not here.
No. Tell me, Devaraj.
Good morning, sir. So I'd like to sir, I would like to request Mahanti sir to speak few words to our participant regarding this FTP. Sir, please, sir.
Good morning to everybody. This is my experience is very excellent about this faculty development program. And this program, the specialty, what I found is it goes to the basics, right? It goes to the basics, and basics, back to the basics like program. So some of the lectures were very excellent, very useful. People who are not working in this area also have a lot of things to learn. So also they'll get some idea. Mr. Patnaik from Orida, he did a picture of the whole country, how we are lacking in this renewable energy. Yes, we are lacking. We have to install more. And especially Professor Nimaigiri, he gave a lecture which is very, very interesting. How to decide the power requirement, what is a solar cell, what volt it does generate, what is parallel connection, what is series connection. It was so nice. It was so nice lecture. I learned a lot of things from that lecture. Second is today what Shruti gave, Shruti Ranjan Naik, Professor Shruti Ranjan Naik. It was application. We are not only learning the subject, but we are applying. I wish all the best for this faculty development program. I thank Mr. Abhinav Vishal and Professor Debaraj Rana. So nicely you have conducted this. And only thing that this series of lectures should continue for at least 5 days, 2 hours daily. So learning will be better. So all the best, good work, and special thanks to your Mr. Nimai Giri, Rasmi, Shruti Ranjan Nayak,
Thank you, sir.
and Shruti, you are very good.
Thank
You
you,
are
sir.
good.
Thank you,
You are
sir.
a practical man.
Sir.
So many people have appreciated your thing. So keep it up.
Thank you, sir.
Now we'll see how it can be commercialized. Okay. The fundamental lecture also about the situation of renewable energy in India by Orida gentleman, Mr. Patnaik, was also very good. So only thing comes from that, we lack a lot in India about this side of this energy, renewable energy matter. Thank you very much. God bless you. Very nice. I enjoyed all these 4 days, 4 days. And thank you very much, Devraj. Thank you very
sir.
much.
Thank you.
Thank
Thank
you.
you for your valuable words, sir. Now, I'd like to request Professor Jagannath Pari sir to speak few words to our participants. Sir, please. Pari sir.
Well, thank you
Thank you, sir.
for calling me. I would like to extend my hearty thanks to all the participants. I find 157 participants from across the country, and I hope all of you must have enjoyed or liked it, learned something, and some discussions also I found quite interesting. Particularly very active was Mr. Sharma. This morning also he was Anup Sharma, I think. Are you Mr. Anup Sharma, na? Devraj?
Oh, sir.
Yes, sir. Yes, sir.
And those 3-4 days I was here, he was quite active, and similarly others also. So I again thank all the participants who made it quite a successful an event. So regarding the program, all of you know, and what next? So as you say, as we all know, everything, every system, every new thing has its advantages and disadvantages. So our renewable and new, that MNRE, the Ministry of New and Renewable Energy, are also doing an R&D on how to overcome the defects in the system. So one major one major thing to overcome in solar energy is disposal of these PV cells, solar panels. So next, I had a word with the Director General of National NICE, National Institute of Solar Energy, I think. So he was quite happy. We will start a series of lecture, maybe next week or the week after next. Eminent speakers will be there about recycling of the solar cells. And in Bombay IIT, some of our faculty have also attended. There were a series of talk and lab experiments. They have a good lab in Mumbai IIT. They are experimenting on optimizing the solar cell. So that design, to optimizing the design of that, and we will also be participating with that. So when we go for the next session will be particularly well. This was mostly a general thing mostly about wind and this thing and its applications, because the solar energy has become popular, it is expanding, and therefore the disposal or recycling of solar cells is of concern. And there are industries which have started. There are industries which are converting certain things they are deriving from the cell, the silicon, the aluminium, etc. So we will concentrate on that in our next lecture series, and I hope all of you will also attend it. And I will say here, tomorrow is World Environment Day on this World Environment Day, also we are having two people. One is the retired principal of Delhi Engineering College, Mr. Bapat. He will be speaking on this particular issue, solar panels. And another person from our local town, Jatni, the municipal chief here, how they are converting waste to wealth. Small experiments they have been doing, and we are fully supporting them as a cultural and social responsibility. He will be telling about that. I hope most of you will also attend that. So let us go, let us do it in such a way that when the session ends, the output of this session goes as input of the next session. So this thing will continue, and this research and development, we will continue through this, the online mode as far as practicable. And I hope all of you will support this. Thank you. Thank you again to the organizers, Abhinav Biswal and his team, and above all the participants, our other faculty members who have been here. And yes, that's all. Thanks again.
Thank you, sir.
Thank you, sir.
I'd like to request Dr. Abhinav Biswal, sir, to say few words to the participants.
Firstly, welcome to all the participants for active participation of this 4-day FDP for green technology for enhancement of livelihoods. Then all the success goes to the participants. Participants are very good, and they are having little knowledge of renewable energy that appreciated. Then all other things are very good. Yeah, thank you very much. Thank you very much.
Thank you, sir.
Thank you, sir.
Now, I'd like to request Dr. Prashanta Mahanti, sir, Dean Academics, Central University of Technical Management, to say few words to our participants. Mahanti, sir, please.
Yeah, thank you, Debras. Good morning to all the participants of this FDP program. I have been, tracking this FDP for last 4 days, but unfortunately, because of parallel session, I could not able to attain on the entire session. I remember when Nimai spoke to me, sir, we want to organize an event, an FDP program. I said, when we think of a FDP, it must spread across the other institutes, and it should not limit it to our institute only. So therefore, please ensure that you get external participants, and then only we will go for it, because this is something which is very necessary for everyone to understand, and also to explore opportunity to find varieties of solution. So he said, yes, sir, I promise I will ensure that we will get more participants. And I was very happy when we could see that about more than 200 participants registered for this program. And so my special thanks goes to NMI for taking initiative and getting enrollment for such a large number of participants. And I do understand, today we are not, as a country, we have not done much in the renewable energy field. So it is, I think, that a responsibility with all academic researchers, academic institutions to spread and create awareness through their students, which would help, going for a massive scale of operations and installation of alternative renewable energy system, both at a domestic and commercial level. So I think we have a bigger role in contributing to this movement. And as we know that we are suffering from the resources that we are in need of, and as I also understand that we have to take care of the environmental hazards that will be coming after this. So I consider that this is a bigger role, not only with the responsibility with the government, also with the academicians, to do research and explore the solution that can be given to the society at a lower economic model, and also to spread awareness through our students, and that reaches to the common mass of the people. And I'm sure also this FDP must have contributed a lot into bringing a lot of insights, and that would lead, that would give a subsequent thought in the mind of the researcher. And I'm sure this is just a program that we listen to the speakers. Rather, we take a greater, we take out some problem or the research areas that the participants can do further study, and maybe that will contribute in the field that we are aiming at. So I want to thank all the participants across India who have all participated. Of course, we are fortunate in one way that because of COVID, we could connect through virtual mode. Physical participation is always difficult, I have seen in the past, but this has helped in other way around to connect such a large number of participants. And I want to thank, I have seen three people continuously working in this research center in our university, like Nimai, Smriti, and Devasri, and of course other couple of faculty members. But these three people I have seen always 100% dedicated to their work and working on this field. So I want to thank, my special thanks to Nimai, Smriti, and Devasri, and all other faculty who are part of this renewable energy centers. And I look forward to have a continuity of such a program as an extension. And also I would can invite anybody from the participants who thinks that you want to do research. We have a research lab, and of course you can, if you are not a PhD and if you are thinking of doing research in this particular field, maybe you can apply to our university to do research as a PhD scholar. Could be in a full-time or part-time mode, and that would also optimize our resource utilization, and we can do further. So we have last date up to 15 June, so maybe you can take a chance to apply for the research work. And so I want to thank every one of you for spending quality time and taking this program into a success and a logical end. So thank you so much for all your effort, and all the best. Thank you. Over to the.
Thank you, sir.
Thank you, sir. Now I would like to request any
One,
participant.
Devraj.
Yes,
Devraj,
yes, sir. Yes, sir.
give me
Yes, sir.
give me half a minute.
Yes, sir. Definitely.
Yes.
Please, sir.
So I would like to really appreciate and all my regards to my friend Professor Jagannath Padi and Dr. Abhinna Biswal, who both of whom who have done a lot of encouragement work to come out with this successful FDP. Thank you, Dr. Biswal. Thank you, Jagannath.
Thank you. Thank you.
Thank you, Arjendra. Thank you.
Thank you, sir. So
Thank you.
Now
Thank
I
you.
would like to request any participant who want to share their experience in these 5 days. Now we are very happy to hear from you people. Anybody?
Good morning, all of you. This is Dr. Acharyulu from Century University AP campus. I had a fortune to attend to 3 days out of the 4 due to some emergency. I could not attend one of the sessions. I found really it is useful because you have given us what is called the real-time applications of solar energy, real-time applications of solar energy in the rural area as well as in agriculture. I am very much, it was really helpful to me, and particularly yesterday's session over wind energy has given me very good information. And I'm very happy to say that you are given what you call live examples. This is what really required for any thing to be called as an FDP or that of a workshop. So my sincere request to the Century University of Management, this time if you conduct any kind of young entrepreneurs conference, that will be good enough. Young entrepreneurs conference. those people who have taken training under you, what they are doing, if they come with what you call the applications, that will be of immense help to all the participants, sir. So thank you very much once again to all the organizers and Century University of Technology Management for having arranged this kind of program. Thank you very much.
Thank you, sir.
Thank you, sir. Anybody?
So, very good morning, sir.
Yes.
Good morning, sir.
It is Muthu Kumaran from NSIC Hyderabad.
Good morning, sir.
So, very happy to see that Century University has been taken very good initiatives in conducting the very good training program on solar system. Especially, I was seeing the class taken by Smriti sir. He has been given very good demonstration about the solar thing and today incubation thing. It gives us a very good level of understanding of the system. Even myself has been got some valuable inputs as delivered by the sir. So all the best for the Century University for taking this kind of initiatives and bringing this and connecting all the technocrats into one platform. So it is very good to see. And I was very happy to see the management has been given the opportunity to do the research work, especially on the solar system. So I hope that the people like us, we will be utilizing these facilities which has been offered in the Century University. So once again, thank you for giving this opportunity for me to attend this FDP. And thank you for sharing the knowledge. That is very, very important. So I hope that in coming days also you will be continuing this same kind of running program, which will be benefit for the educational professionals as well as industrial people. Thank you, sir.
Thank you, sir.
Thank you.
Hello, sir.
Yes.
Am I audible, sir?
Yes.
Yes. Yes.
It was a very nice program conducted by you people. Well organized, well planned, and the knowledge is very ground reality based knowledge, and the experts are quite good in their area. So their research can be utilized for the benefit of the society and benefit of the student also. So it's really thankful for me to join this kind of program. In future, if you in Rajasthan University, I am Dr. Padmana Varun Gadage, working in Rajasthan University as a professor and PhD cell in charge. If you feel any kind of research or PhD program can be conducted over here on a guide basis, anything like that, you are welcome over here. Recently, we are publishing the ad at 15th of June. So this was a very nice area to work on it. Thank you, sir.
Thank you.
That's all from my side.
Yes, sir.
Thank you.
So thank you all. Now I would like to request Dr. Ashish Ranjan Das, Coordinator for Center for Smart Infrastructure, Century University of Technology and Management, to give the vote of thanks for this activity. Please, sir.
Good morning, all the dignitaries and participants over here. So on behalf of the FDP Faculty Development Program, Green Technology for Enhancing Livelihoods, it has been organized from 31st May to today, 4th June. And it has been organized by Center of Smart Infrastructure in association with CRE, that is Center for Renewable Energy and the Environment, and the Department of Electronics and Communication Engineering. For the whole support of this FTP, I want to thank the guest here behind this, Dr. Muktikanta Misra, President CUTM, and Dr. Supriya Patnaik, Vice Chancellor CUTM, and Dr. GSN Raju, Vice Chancellor CUTM AP Campus. First of all, the thank goes to the participant for attending and make this FTP successful, and whatever the comments we are getting already, it is encouraging for us that this FTP goes in a well way, so which can also lead to different research activities like conference, journals, like this concept what has been delivered. It will definitely make us around with different prospect of research, which can lead, that is our main aim of this research, where this FTP when you conducted and you can plan already, and this we are thankful to all the technical talks. The first day we have renewable power for sustainable development. I thank the resource person Dr. Josna Singh, University of Lucknow, UP. Day 2 we have utilization of renewable energy for rural livelihood in agriculture and allied sectors. I thank the resource person Dr. Mahendra Kumar Mahanti, OUT Vignesha. And day 4, day 3 we have solar PV design sizing, and I thank to the
FDP coordinator also here, Professor Nimai Chandra Giri, and also a resource person. And on day 4, we have wind energy conversion system. I thank the resource person, Professor Bivu Prasad Gantia Ijik Sarang. And for the topic livelihood products of rural revitalization, the resource person, Mr. Arupananda Patnaik, Oreda, Bhubaneswar. Day 5, we have live demonstration of livelihood products. And also I'd like to thank the people behind this FTPs, our chief patrons, our president, Dr. Muktikant Misra, Professor D.N. Rao, vice president, patrons, Dr. Sukhya Patnaik and Jason Rajusa, our advisor committee, registered Dr. Anita Patra, Professor A. Mohanty, Provici, Professor Jagannath Padi, director, Dr. Prasan Mohanty, Dean Academics, Professor Satya Prasad, Dean Academic Admin, MSSOA, and Dr. Amina Chandra Vishwar, Professor P. And the technical committee members of the coordinator, especially to Nimai Chandragiri and Mr. Dibraj Rana for organizing this FTP. And lastly, I had to thank all those who will be associated in future with all these FTP. Also from the Center of Smart Infra, you are going to organize very much other events also. Before ending, I must thank the IT administrators, UTM, Mr. Nusingha Das, and for Mr. Chandan for the server room. And also, I like to thank Professor Kulbhushan Pradhan, Soviet UTM, for the information he has shared through the FTP to all the participants. And also Atila Binayar for 4th year student department of ECE for hosting the inaugural session. Thank to all who directly or indirectly involved in this FTP to make it a successful one. From our research center, we are going to organize one more FTP in the coming this month, June we are planning, and the date will be scheduled. Obviously, we'll share you the topics and the dates, and I'll be happy if you all can join this other FTP and make it successful, and we'll promise you to give more research content and will be more good towards the FTP where the resource persons will more related to the practical things where the research can be updated or your area can be more discussed. And thank you once again. Thank you. Devraj, you can take over now.
Okay, thank you, sir. From our coordinator side also, I would like to thank Dr. Asit Ranjan Das for his support and to make this event successful. Thank you, sir. And with this, we are concluding our event. And from the organizing team, a very big thank to all the participants. Hope we'll see you soon in the further future event. And thank you all. And I have submitted the feedback link. Please, it contains one test also. You please submit it and I will enable till 12 o'clock. After that, I will disable it. So, sorry, it's not 12. We have now 11. So, at up to 11:30, I will enable it. Then I will close it. So, with this, a very nice journey we're having this 5 days with the experience regarding this renewable energy resources and how it has been utilized in this livelihood, sustainable livelihood. And we hope we'll see you once again. So thank you all of you. Thank you all. And also I'd like to thank Professor Nimai Chandragiri for his support and coordination so that we make it successful. And thank you to Smitaranjan Naik sir for his beautiful demonstration regarding these products. And thank you all the people who have involved to make it successful. Thank you all. So we are closing the session now.
Thank you, sir.
Thank you, sir, and thank you, participants.
Thank you, sir.
Thank you, Devraj.
Thank you, sir.
Thank you.
So feedback link कहाँ share की sir?
Sir, it is in the chat
box.
Okay. Thank you, sir. Thank you very much, sir.
Thank you, sir.